Use properties of similar polygons to solve for a missing side or anything else that's missing in the polygon. So first, let's refresh what we know about similar figures. Well, similar figures or polygons are the same shape but different sizes. So we could say like this rectangle and this rectangle. Same shape, different size. But the key is this last point, that the corresponding sides have the same ratios. If that last piece is not true, they are not similar. What that means is here you see we have two parallelograms. We have one on the left where we have sides 4 and 12, and on the other side we have sides 8 and 24. For these two to be similar, that means the short sides, 4 compared to 8, have to be in the same ratio as the long sides, 12 to 24. Now you'll notice I put the little parallelogram on the top and the big parallelogram on the bottom in terms of consistency with ratios. Okay, now when we're looking at this, 4 compared to 8 is 1/2, and 12 compared to 24 is 1/2. So there's your similar ratio. The sides both reduce to 1/2, and therefore we have ourselves similar figures. So in the first example, the given trapezoids are similar. Find the unknown side. All right, so when we're given the trapezoids here, we notice that we have, I'm going to call this the little trapezoid with a short base of 10 and a long base of 16. And then the big trapezoid has a short base of 25 and a long base of x, which is what we're trying to find. So when I set these up, I'm going to set up little trapezoid on the top and big trapezoid on the bottom. Okay, so with the little trapezoid, short base of 10, that compares to the long base of 25. And we know that the little trapezoid of 16 will compare to the big trapezoid of x. Now, because we don't know, we can't just reduce them to see if they work. We're going to have to solve a proportion. So, refreshing on solve a proportion is simply two ratios, or two fractions, set equal to each other. To solve this, we are going to, what we call, cross multiply. So the denominator of one ratio is multiplied by the numerator of the other. So I have 25 times 16, and that's going to equal 10 times x. Well, 25 times 16 is 400. So I have 400 equals 10x. And to get x by itself, we're going to divide both sides by 10. And so x equals 40. So that tells us the long base of the big trapezoid has a length of 40. And just look kind of at a reasonable piece. When we look at the little trapezoid, 10 and 16. So obviously the long one is a little bit longer. And then compare the big one, 25 to 40. It makes sense, right? You just want to make sure that you didn't get a weird answer like 7, because 7 wouldn't make sense for that value. You just want to make sure it makes sense. All right, one more. The given hexagons are similar. Find the value of x. Okay, so again, remember, similar figures or similar polygons means they have the same shape, different size. Okay, so they're both hexagons, and they have the same angle measurements. So if you think about rectangles or anything else. So the fact that these are similar means that all of the angles are going to be the same. So because this angle is 120, that means x is also 120 degrees. So the corresponding sides are proportional in a ratio, right? They have the same ratio, so they're proportional, and that means that our corresponding angles are congruent. So that's another piece of similar polygons.